Okay, so I have a piece of geometry here that I want to fracture based off of when a particle hits the surface. So we're gonna do a quick setup for that. I already modeled the cement barricade here, and I'm going to jump inside and I'm gonna fracture this object. So I'm gonna create a ISO offset. So to create that and smoke, if we want to make it a little bit more defined, we can increase the resolution. Then scatter points in that volume. And then we're going to do a Voronoi fracture. And then we'll connect the second input into the points. And we should have the fractured geometry like this. We can increase the number of points if we'd like. So that looks good. Let's see if I bring it up to 100,000. I think that's going to be a lot of points at 100,000 and it would work really well, but it's going to be a little bit slow for the tutorial. Let's just see what it looks like really quick. While this is going, let me pause and then we'll come back. Okay, so this is how it ended up turning out. And I really like that. I might come back later to this resolution, but I think I'm going to keep it at, actually, just to make it easy for what we're doing right now, we'll bring it down to 1,000. And then when I'm doing the final version, I'll kick it up to 100,000. So that is working well. We have a geometry that's fractured. Then here, what I'm going to do is tell it that I want it to be a fractured rigid body. So if I go to rigid bodies, I can go to RBD fractured object. Packed objects is fine. It's going through and calculating everything for us. I'm also going to turn on collisions and make a ground plane. So that way we can see it collapse. So this is how it is working right now, where it's just falling apart. Oh, I was doing a test render earlier, and that's what that error is that this is running in the background, and it was trying to render at the same time as this was simulating. Okay, so that looks good. Now we want this barricade here to stay together in a single piece. It's actually going to end up being in the Autodot network, but let's go to rigid bodies. We can go to glue adjacent, select the RBD packed object here, and then push enter on the numeric keypad, and that should glue our object together. We get a lot of extra nodes. I'm going to push L to lay everything out cleanly for us. And by default, this should keep everything together. I like that. I'm going to adjust the strength. So if we bring this down to low strength, it's going to be able to be broken just with like gravity. You can see we get the breaking like that. But what you'll notice is if we put it in a negative value, it's actually going to hold together no matter what. Then we can actually break the connections here in the remove broken. We will actually be breaking the connections exactly where the collisions are happening. So let's create a particle source, and I'm going to just do a location particle emitter. Click on that, click on the ground, and let's bring this up. And let's bring it up maybe around 0.8. and 0, -1, just to have some cleaner numbers. Actually, let's put this -2. So it's a little bit further back where it starts. Okay, so if I go back to the beginning and I play right now, I have a whole bunch of particles coming out from the emitter. Let's push L over here on the auto dot network to lay everything out. On that location emitter, I want to make sure that the birth rate is lower. So let's do something like 24. So there's going to be a lot less particles that are coming out so that we can see the individual impacts. Now let's add velocity, and it's going to be moving in the Z direction. I'm going to add like 10. And we should see that they're coming off and they're bouncing off the surface. Right now it's not breaking anything because we need to tell it to break the connections first. If we click on the pop solver, we can also tell it to on collision behavior when it collides to die. So it's just going to hit that surface and it's not going to bounce off. It's just going to immediately die. So we can see that we don't have any particles bouncing back out this way. And if we would like, we can also do a pop replicate here, and let's bring this down to, actually that's fine, but emit from attribute and let's say dead. So that way it only replicates particles when a particle dies. So we can see that we have kind of like a set of particles that are being emitted from the impact. And then life expectancy, let's put this down to like about half a second, and a variation of 0.3 seconds. Let's do 0.25. Okay, so now when it hits, we have some particles that are coming out from that. It's actually living quite a bit longer than I'd like, so let's do 0.25 here. So they could live up to half a second. And they should die. It's still a bit longer than what I'd like. Let's do 0.1 with a variation of 0.1. Actually, looking at this, it's not resetting. So let's go back out here and reset simulation. And let's take a look at this now. I think that's okay. And we can play around with this, and maybe 500 is too much. We can adjust the life expectancy if we wanted to be 0.05. And let's see that. I like that a lot more. Okay. Now we have these particles being emitted. And what we can look at is the location particles. When we are looking at the location particles, we can see that we get all those particles coming out, being emitted from that. And then what we can do is go back into the auto dot network. Actually, before we do that, let's go into the location particles here. And let's create a null so that it's easy to find. And we're just going to say out underscore particles. Okay, and then I'm going to go to the auto.network and double click on the remove broken. I'm going to remove that delete, so it was never gonna break anyways, but we're gonna rebuild that. And we're gonna do an object merge. We are gonna look for that null that we just created in the location particles, the particles. Except I'm gonna turn these add a color and turn them white. I'm gonna alt drag over here and connect these this color here, but I wanted that to be black. Okay, so we have white particles going onto a black surface here. And what we're going to want to do is transfer the properties from these particles to this geometry so that we can delete it based off of its color. So I'm just going to go in and do a attribute transfer. The first one is the geometry to transfer attributes to, and then transferring from this object here. Let's look at this. And what we will see is that if we play, it pretty much immediately goes to white. So we have to adjust some settings. Now let's go to the conditions here. And over here in the distance threshold, I'm going to bring this much lower. Let's try 0.1. And when we play, we should see once hits are happening, we're getting breaking there that we are going to be getting. So that is good. The only thing is that we're actually also getting the replicated particles being part of all of this. So I'm going to move to hit. So basically it's going to have a hit group or hit property that actually do a collide group. No. I'm going to do move to hit, and we'll try that first. Let's go here to our particle locations, and let's try going here and create a blast in here. Hit. That is not liking it, so we don't have the hit parameter there. Let us go back to the auto.network, and I'm going to pause to figure out exactly what the property is that we need to do, so that way we can just blast those points when we're calculating for the remove broken. Okay, so this is how we are going to do it. We're going to go into the auto.network, and in between the location and the pop replicate, we are going to add a pop group. Now that that's connected, I'm going to tell it to preserve group, and I'm going to give it a name. I'm going to call it init part, so initial particles, and then basically enable so that it's group, it's in this group. So now if we come over here and we play, we should still have everything, and then when it collides, it's creating those other particles. But what we can do is create a blast node, And then inside of this blast node, we should be able to select from a group. Let's make sure that we are having everything come in. Let me go into a frame where we would see it. Let's bypass this for a moment. So play it. Now we have some particles in the scene. Let's see if those groups come in, and they are. So I'm going to say initial particle, but delete non-selected. So let's turn this back on. And then now we should see that we get those particles after that point, but they're not being replicated. But over here, if we're looking at this version, we are getting the replicated particles. Right now that is falling, but if we go here to Auto.network, network, reset simulation, we should get it where it doesn't fall. It's just having a little bit of issues because we're trying to calculate the particles and the rigid body at the same time, but we'll fix that before the end. Okay, so now that we have that, I'm going to go into the remove broken, and we should be able to see that we are getting the white pops, hopefully. Let's go back here. Let's make sure that on this, we're at this point. It's looking here, and actually, we need to reset the simulation so that it will calculate. Then go back into the remove broken, and let's push play, and we should see that we are getting white pops. We are not, so let's make sure that over here we are seeing particles. We are not. So let's look at this. Oh, I'm looking at the wrong thing. This is what I should be looking at, and we should see particles. Yep, we are getting particles. And then here in color, they should be white. They are. Here the attribute transfer. So by this point, we should have gotten some points. So I'm going to increase the distance threshold. And then let's recalculate this. There we go. So maybe 0.3 is a little bit much. And put it 0.2. Because we didn't have those replicated points, it needs a little bit of a bigger range because particles die immediately on contact. That looks good there. Okay, so we're getting some hits and the particles changing the color here. I'm going to put it 0.25, kind of in between the last two. Okay, I like that. Now what we need to do is add an attribute promote. And what we're going to do is take the color, so CD, we're going to bring it from points to primitive. Then we're going to add a blast node. And on this blast node, we're going to say @, which tells us attribute CD is greater than 0. So anytime there's any color on those that is more than black, so anything that's grayscale or so forth, it's going to delete the constraints on that surface. You can see that it kind of like grows as it goes along. Later on, when we have more pieces for the fracture, we can actually probably decrease this number because it's going to have to search for less of an area. But for what we have now, let's take a look at what we have. So I'm going to reset the simulation and let's play. So we're not seeing anything at this state with it breaking. And we can actually just visualize this because we don't need to blast it. We just need it blasted for the calculations. So we have everything correct, but the problem is that we have the pop solver and the rigid body all trying to calculate at the same time, and we can see that here we're getting a warning. And if we let's get to a point where it's trying to calculate, it's saying SOP solver cooked immediate mode cache results incorrect. So what we're going to have to do is actually export a cache. Right now I'm going to go to my D drive. I have a cache folder. This was a test that I was doing before. I'm going to just call this maybe new hit. So I'm going to say new hit dot $sign F4 dot sim. Accept. And then I'm going to calculate from frame 1 to 48. And I'm going to tell it to save to disk. It's going to pop up a window. It's going to basically calculate everything, but it's kind of saved everything that's been cached. So I'm going to stop this really quick and reset the simulation before I do that. So let me escape, go back to frame 1, reset simulation, and let's go inside here. And then save to disk. It's going to pop that up and it's going to do all the frames for us. I'm going to pause and I'll be back once it's done. Okay, so it saved everything out. So what I want to do now is create a file node. And let's create a switch here. It's going to go to the file, then this, and then to the out. Right now we're looking at the file, so we have to point to the cache that we have here. By default, you might see it as something like this. Make sure you turn on show as one sequence, and then we get this frame here. Accept. And right now it's set to no operation, so we don't see anything. What I'm going to do is read it. So there we can see that it's working the way we are kind of expecting it to work. And that's working really well. So what I am going to do now is go back to our barricade and let's increase the number that we have here like we said before. Let me save here before we go much further. Forced total count, we're at 1,000, 10,000, 100,000. And it's cooking everything. We have a lot more points. Let's visualize it here at the Voronoi fracture so we can see. It takes some time. And it's going to be quite a few seconds, so I'm going to pause here. Okay, now we have the larger amount of particles. I'm going to go all the way down to the DOP import, and I am also going to drop into here, and on this we are going to change the distance threshold. Let's put it at 0.05. Okay, and then we're going to be at frame 1, reset simulation, and jumping here, and on the switch node, I am going to switch to input 1. So now it is reading this, and it's going to take quite a bit of time to calculate out that frame because it has to update all the geometry now. So let me pause and then we'll come back to this in a moment. Okay, it's calculated everything out. And basically at this point, if we look at it here, we have a much denser geometry, which is to be expected. Come back out here. And what we're going to do is on the output, we're going to save this to disk again. And as this is going, it should take quite a bit longer than the last one. So I'm going to pause here, and when it's done, we can look at the cache file. Okay, so for me, with my system, that was taking too long. So I'm going to adjust some settings. I'm back at 0.25. Let's put this at 0.1. And then we'll jump back out to the barricade, and on the scatter points, we are at 1,000. Because my system, I had to force quit it, so I have to reset this again. Let's put it at 10,000. And then we can go back over here, and let's turn the switch on to 1. Okay, and then let's reset the simulation. And now with 10,000 points rather than 1,000, we'll try this. So in the output node here, I'm going to just save the disk, and once this is finished, I'll be back with you guys again. Okay, so that went through. We're still in read files here, so on the switch node, I'm going to switch it back to 0, and let's play it through. Okay. Let's look at the barricade here. I wonder if this recalculated. Oh, I have 1,000. I meant to do 10,000. That looks a lot better. Go back to DOP import. And then on the auto.network here, let's switch over to input 1 and go back to frame 1 and save this disk, and we'll try again. Okay, so now it is done caching. Let's switch this back to input 0 and let's play it. And it is, there we go. Took a little bit before it started hitting some of those points going through. So it's hitting. So that means that the distance threshold is too low. I am going to extend this up. Let's try, it was 0.25 before. Let's try 0.2 because I don't want it to destroy too much. I want to do as little as possible each time. Okay, now that I've done that, let's switch the input to input 1. And we can go here and save to disk, and we'll be right back. Okay, so let's check out this cache. I'll go back to switch node, switch it over to 0, and let's play it through. So that didn't work. Let's go back to frame 1, reset the simulation, and then let's double check this here. That's fine. Let me just see the first few frames. So it looks like it's completely being removed immediately, which is not what we want. This one should be white for the particles. This should be black. It is struggling here. Oh, it's because we're still on input 0. Let's switch it over to input 1 and reset the simulation. Go back into the auto.network network and we can look at it here, and let's see if we can see just the first few frames. I think around like between 7 and 10, the attribute transfer will start happening. And actually, let's stop this because we are on the wrong section. I just want to go here and make sure that we are seeing some white with the values that we have for the attribute transfer. And we should see some white popping up soon. And what did I have the value at? Did I change it? 0.02, let's put it at 0.2. That's going to go through and calculate all the way up to this point. Okay. Now hopefully we should see some white coming over this way. And just wait a few more frames. There we go. Okay, that is working. So I know that it should have an impact at by 1. Let's do 0.1 and see if that works better for the impact to be kind of smaller, but it's still being able to register. Because looking at the 0.2, it was quite a big area, I feel like. So here we should see next couple of frames it coming in. See frame 8. Are we getting any color transfer? Not yet. We'll wait all the way up to 10. Okay, so 0.1 is going to be too small. jumping back to frame 1. So the distance threshold, let's put 0.15. See if that's enough. So we should see it most likely between like frames 7 and 8. There we go. I like that. I like that a lot. Okay. So I'm going to stop this, go back to frame 1, come out to the object level, reset simulation, and let's try caching this again. So I'm going to put it, oh, we are on the correct input, and then here, I'm just going to tell it to save to disk, and we'll see you guys in a little bit once this caches out. Okay, let's see the results here. So going to the switch, switching it to input 0, checking this out, and then let's play the sequence. So it's hitting but not breaking, which is a shame. Okay, so let's go back over here. We'll put it at 0.25 that it was before. And then hopefully we can break more connections. Here, put it back at input 1. And the auto.network, let's reset simulation. And we will go back out here and save disk, and we'll try one more time. Okay, I realized what the problem was. I was checking this sequence again, and basically if I go back into the broken, actually I'm in the middle of the sequence, let's go back to frame 1. So in the remove broken, I actually have the I on the attribute transfer. It should be on the blast. So I think it would have probably worked at that lower value that we had. And then just turn it on over here. I think it was 0.15 where we were actually starting to see some breaking happening. So I'm going to try that again with the I visible on the right node. And then we're here on 1. That's fine. Let's cache this out. Okay, the cache is done, and hopefully if we switch over to the file node, we should see some breaking, and we are. So this is looking pretty good. Let's put it real time. It's not going to look super because this is 2 seconds, so we should actually see a lot more of this. So what I'm going to do now that we have this cache made is create a flipbook so that we can see kind of the timing and what that looks like. So do this, and we'll just do the range. That's fine. Start, and I'll be right back once this flipbook is created. See you guys in a moment. Okay, the flipbook is done, and if we play it, we can kind of see what is happening now with the particles. So it does take a few hits before it starts really kind of damaging it. but I think that looks pretty good. So I'm going to stop this, and then let's go ahead and start looking at some of the rendering. So I'm going to put it at frame 14, and let's just do a render here to preview kind of what it's going to be looking like. And right now we can see how big those particles are. Obviously we want to update that. So let's go back up to the object level, and we're going to go into location particles. Here we're going to come out, and let's do a blast. Actually, let's just copy this one over. So, and on this one, we're going to do that. So here we'll only see the particles that are replicated, and here we will see only the particles kind of coming in. So I'm going to create a, let's stop this really. Actually, we will, that way we can control each one individually, and what we're going to do is actually merge them together. So bringing these in together, merge. So when we merge them and we visualize it here, we see everything. But that gives us the ability to control each particle to look different. So with this, we can do like a color. And let's make this kind of like a dark color. Actually, I want that over here. And really where I want it is here. There we go. So that way we are controlling the color of that. And I also want to adjust the scale. So I want to make this kind of a smaller projectile. So let's go ahead and create a attribute VOP, or actually I could do a point VOP. And then connect it here. And I'm going to double click in here. Let's create a parameter. This is going to be named scale. And we're going to connect this into a bind export. And this bind export is going to be based off of the P scale. And we should see that those disappear now. And that's because if we jump back out here and go to point scale, the scale is at 0. So if we put this at 1, we should see that they're much bigger. 0.1, we should see that they were a little bit smaller. 0.01. There we go. So we have kind of smaller projectiles coming out there. And then on this one, we're going to add a color too. And let's make it red. Try somewhere around here. Stop the render really quick. Get it out somewhere around there. And we can push play. So we're still not getting the other ones. Let's add a point VOP over here. And once I do that, we can see, because we gave a point scale on this side, now that we have the point scale, we have that popping up. And on this one, just make it even smaller. Maybe that's a bit too small. And that is good. I like that. And that's going to be kind of like sparks eventually. So another thing I want to do is just go to the out node and let's turn on in rendering tab motion blur. So we should see some motion blur here. Actually, we're not seeing any motion blur, and that's because we need to turn on velocity on the render setting for the sampling. So right in here it says no velocity blur. Let's turn on velocity blur here. And now we should see these elements here. And that looks okay. So what I want to do also is add material. So this is the spark side. Let's do a material here. And let's create that material. It's going to be based off of principled shader. There we go. And let's try something like that. And then an emission. Let's do red. Let's put this at 0.01, 0.01. It's still going to look red, but that will give us an opportunity to adjust things. And the name, let's call it Spark. And let's go back to object level, go to the location emitter, and here let's assign the material. So we have material, spark, accept. So we kind of have it going well right now. Let's go to the material and make some adjustments now that it is assigned. Let's see if we overshoot the emission, what that's going to look like. We'll render it again. And let's take the yellow here, and let's put 0.01 here, and then I'm gonna try to overshoot the yellow. And then let's stop and render. Let's go back to the object level. Let's stop the render for a moment and let's create a camera. New camera. It's going to create it exactly where we were, but that also gives us the ability under sampling to adjust the shutter time. So in the render view, I'm going to make sure that we're rendering from camera 1. And let's see what that looks like. It should be pretty similar. Okay, so if we decrease this, we're going to see less blur. So you can see that it is less blurry overall. And if we increase it, we should see more blur. So try something like that. And then on the location particle here on the particle scale for the projectile. Let's try it 0.05. So it's still too big. 0.03. 0.02. Okay, I like that. And then we can adjust some lighting and stuff. This material, though, I'm not happy with yet. I wonder if it's going to look much different if we put it at 0.01. Okay, let's take this color and maybe make it white. Okay, so we have a white color, and then the material, we can use the point color or not use it. Let's see that we have to update the render here. So if we don't use it, let's look at where we have the eye on that node. We do have it all the way down on the merge, so that's good. We have the spark, that's good. Okay. Let's do 1 and 1. I'm just trying to get the emissive quality much stronger. Let's put this at 1 and render. And this is just a lot of little tweaking to try to get it looking the way I want it to. So if I use point color, and it looks like it's not really using the material. Let's see if we go here and add the material onto the node level or the object level, if that changes things. Yeah, we can see now we're getting that high glow. So what I'm going to do here to be able to get the particles, so let's remove this, and inside of here, let's not merge it together, and we have it visualized on the side of the projectile. So just double checking that. Yep, that's what we're seeing here. So I'm gonna now over here create a null node, and we're gonna say this is out sparks. And then I'm gonna create another geometry node here. Let's call this sparks. And here, what we can do is do a object merge. And we're going to go select inside of the location particle, out sparks, accept. Now we can go to the object level here, go to render, and make sure we assign that material. And under sampling, make sure we turn on the velocity blur. And let's render this, see if we're getting the sparks looking the way we want it to. That's great. Over here, I'm just going to, now that they're actually like showing up, try to adjust the size so that way they're not super big. And then this projectile, let's say we change the color to something like a blue. So it's almost like a laser hitting it. And then we'll create a material, drag that over here. And emission, use point color. And let's assign that back at the object level. So on this one, material, I'm gonna go assign this one. And then let's go back to the materials and start adjusting this. Let's double click this. I just want to be able to adjust the name. Okay, and then let's change this. There we go. We're getting a color kind of like that. Okay, maybe can set this to white here. Let's see if we can get the core to be a different color. So let's not use this. We'll put this back at 1. So we should get it kind of blue. Do that, and then let's take the emission intensity, because it looks like we're starting to get that here. Zero 1. 10, 10. So if we get something with that. One, 1, 1. just going back and forth and just trying to get the look exactly the way I want it to be. Doesn't look like we're adjusting much of the look here. See that we're getting some glowing of that blue there, which is better. Somewhere in between. There we go. We're getting that kind of like blue glow on the outside of it, where it's kind of getting kind of a warm color in the center. Not warm, but a white color. There we go. That is looking a lot better now. So we have the albedo modifier or multiplier at 4. We're not using the point color. We're basically assigning it the color that we want over here. And then we're really overshooting the emissive color so that we get the colors there. Then we can go back to the sparks and kind of have that here. So if we do this like at 100, let's do this at like 4. Not use the point color. 2. There we go. We got more of a spark look going with those. And then what I can do also is at the render node here, I am going to turn up the samples. Let's do 6x6. And that should clean up some of the noise. Still rendering pretty fast. Let's try 10x10. You can see that as we increase the samples, it does really slow down things, but you can see that it looks much, much better as it's hitting here. Minimum of 4. And just trying to see if we can adjust some of the settings. Let's see, shading. Let's try switching it to physically based rendering. Let's see if that looks any better. And a lot of it at this stage is just kind of tweaking the look. So maybe about a minute per frame right now. Let's bring this up. See if it's in the reflections that we're getting that detail. Let's see, when I calculate out an area like this, that's looking a little bit better. Okay, so let's compare that to it being at 1, and I'm just going to calculate this kind of area over here. Yep, so this reflection is where we need a lot of the information. So let's try bringing this down 3 and 3 and only bringing up the reflection quality. Let's go 6 and 6. That looks pretty good. So we don't need to go all the way up to 10, and it looks pretty good there. Looks like maybe about 2 minutes per frame. It's not 2, but 3. If we do it 3, we're at about 30 seconds a frame. I think just for this project to have it look okay, I'm going to want to bring this kind of up here. We can overshoot this too. Here we're just calculating all those samples. It still doesn't have, oh wow. It's probably about 10 seconds per frame, 10 minutes per frame. So what I'm going to do just for this project, I'll put it at 3. We got about a minute and a half. I think this is going to be okay with all the motion and everything. Okay, let's stop this. And then I'm going to make an adjustment to the barricade. So over here, let's check blast really quick. So here we're blasting everything. Do we have the groups? We do not have the groups here. So I want to assign it up here. Although we baked out everything already. Let's see if we can add the color here. If it goes all the way through, because we're reading it from memory now. Okay. Let's look at the DOP input. Let's do fetch geometry from packed geometry. And let's check this blast. And do we have anything here? Nope. Let's do fetch unpacked geometry from dot network. Let's see, do we have the groups? There we go. Now we have the groups. So like we can delete the outside, for example. But what we're going to do is add color. And we're going to do it based off of the groups. I'm going to do outside. And then here, let's make this kind of like a dark gray. So when we look at it here, we have that. And then let's add another color node here. And that one, we're going to filter it by inside. And then on the inside, we are going to switch it to a lighter color. So that's inside versus outside. That is good, but it's bleeding over. So instead of doing to points, I'm going to do primitives, and that works for what we need. And then same thing here. I'm going to switch it from points to primitives. And then we should get a better looking fracture there. So when we play it here, we should see that we're getting kind of that look happening here. Then on this, let's go somewhere over here. I also want to turn on the motion blur for this. So let's turn on the velocity blur here. And let's see if we're getting any blur on those elements there. So I'm not noticing any blur here. So let's look at the barricade, and we have point trails and display normal. So we want to turn on point trails. And we can see that we're not getting any velocity on any of this geometry here. So what we can do is point velocity. We'll add that node here. And then it's basically going to calculate out the velocity for us now. And let's go back out here and look at the render. Do another render. And we should see in this section here, we're going to be getting motion blur now. Yep. And there we go. So we have to turn on the velocity blur to be able to get some of that going, and add point velocity to this because it didn't have any velocity to begin with. All right, this is looking pretty cool. I like it. So from here, I'm gonna pause the video, save the scene, and what I'm going to do is just kind of clean up the environment, set it up to render, and then render out the sequence. And when we get back, we will have a full render of the sequence so that you can look at the final product. But this is just kind of the polishing stage at this point. Okay, so this is how the final look of the render. It's the 2 seconds of the render that I did. And we can see that the lasers are hitting the geometry here, and it is causing it to break. This is this project. I hope you found it useful, and we'll see you guys in the next video. Bye.